This experiment investigates two key properties of concrete, compressive strength and flexural strength, using cylindrical and beam specimens. These strengths are vital for structural stability, reflecting resistance to axial and bending stresses. The goal is to measure these strengths and assess how handling, curing, and blending affect them, using standard testing methods. Proper specimen preparation is critical for consistent, reliable results with deviations indicating possible process flaws. Procedures for beam. Turn the test specimen on its side with respect to its position as molded and center it on the bearing blocks. Center the loading system in relation to the applied force. Bring the load applying blocks in contact with the surface of the specimen at the third points between the support. If full contact is not obtained at no load between the specimen and the load applying blocks and the support,
3 days later,
so that there is a 25 mm or larger gap in excess of 0.1 mm, grind or cap the contact surface of the specimen or shim with the leather strips. Apply the load rapidly up to approximately 50% of the breaking load. Thereafter, apply the load continuously at a rate that constantly increases the extreme fiber stress between 125 psi and 175 psi per minute until rupture occurs. Procedures for cylinder. Measure the diameter of the test specimen to the nearest 0.25 mm by averaging two diameters measured at right angles to each other at the middle height of the specimen. Adjust the bearing block into position. Clean the faces of the bearing blocks and the specimen. Carefully align the axis of the specimen with the center of the thrust of the
1 million zillion jillion dillion cotillion times later,
spherically seated block. Apply the load continuously and without shock. For hydraulically operated machines, apply the load at a constant rate within the range of 20 psi per second to 50 psi per second. Continue applying the load until the specimen fails. Record the maximum load carried by the specimen during the test. Note the type of failure and the appearance of concrete. This experiment investigates two key properties of concrete: compressive strength and flexural strength, using cylindrical and beam specimens. These strengths are vital for structural stability, reflecting resistance to axial and bending stresses. The goal is to measure these strengths and assess how handling, curing, and blending affect them, using standard testing methods. Proper specimen preparation is critical for consistent, reliable results with deviations indicating possible process flaws. Through this experiment, students gain a deeper understanding of concrete strength and elasticity in a real-world engineering context.